Tonight marks the pivotal moment. In just a few hours, 3I Atlas, the enigmatic emerald-shining interstellar intruder that's had astronomers on edge for months, will glide by Mars. The events unfolding over the coming hours could reshape our discussions on comets, extraterrestrial objects, and perhaps our very understanding of humanity's role in the universe. This isn't practice. It's the instant when observations either confirm a slew of troubling theories or compel us to revert to the comforting narrative of mere frozen debris. For those tracking its journey since detection, the specifics are already deeply unsettling. Unlike typical comets, discovered through routine scans and exhibiting expected patterns, 3I Atlas emerged differently. Right from the start, it displayed erratic fluctuations in luminosity, far exceeding what solar warmth alone could explain. Its spectral signature is overwhelmingly rich in carbon dioxide, unlike the water-dominated profiles of most comets. Imaging specialists repeatedly observed hefty, sluggish dust particles and abrupt luminosity spikes that resembled deliberate propulsion bursts more than haphazard gas ejections. Then there's the hue, a peculiar verdant aura that defies alignment with standard comet compositions. Collectively, these anomalies weave a tapestry, prompting some experts to murmur terms they rarely utter. Artificial scout mission. With Mars directly in its trajectory now, those murmurs demand scrutiny. Soon, Earth will drop out of direct view. For a brief span of days, our world will be sightless during the object's nearest pass. Thus, the sole constant observers in the solar system become the automated probes orbiting the rusty world and the limited sun-gazing telescopes capable of peering close to our star. Mars Express, MAVEN, TGO, and fellow satellites have been assigned intensive, frequent surveillance duties. Ground-based rovers, weather and data links permitting, stand ready to record any abrupt variations in ambient dust, illumination, and ionized particle flows. These devices represent our only impartial observers, and this evening their incoming signals will eclipse any newsflash in significance. Astronomy often tempers the unexpected by folding it into established protocols, presuming that measurements will conform to proven laws once the hardware performs. Such optimism lingers. The prevailing theory embraced by numerous project leads remains straightforward and recognizable. 3 Atlas is an interstellar comet boasting an atypical makeup, originating from a frigid remote star system that endowed it with abundant CO2 and denser particulates. Buried layers of reactive ices might erupt sporadically. Bizarre tail formations could stem from substantial dust, clashing with solar radiation and magnetic influences in manners our simulations haven't fully grasped. These explanations hold water, and experts wisely pursue them initially. Yet, feasibility doesn't equate to evidence. 3 traits persist in haunting the field. Firstly, the approach angle and layout. This entity's inbound route clings to the ecliptic plane far tighter than usual for interstellar wanderers, a pathway evoking intentional design. Secondly, the rhythmic luminosity. Rather than a steady ramp-up from thermal effects, the body has exhibited on-off cycles at semi-regular paces, syncing with brief velocity tweaks noted in separate positional datasets. Thirdly, the chemical quirks. Elevated CO2 to water proportions, plus sporadic surges of unforeseen metals, have been documented by multiple observatories. Individually, each might find a rationale. Combined, they build an argument too compelling to dismiss. This night, researchers prioritize spotting 3 key indicators, primarily disintegration. Should 3I Atlas fracture under solar influence, the debris configuration reveals its core makeup. Shattering into numerous tiny bits points to a brittle, spongy heart. An explosive outgush of vapors and particles in a grand burst hints at volatile-laden stores. Secondly, abrupt course alterations. If the trajectory deviates beyond forecasts following an outburst or split that might signal uneven mass shedding, or, taking the bolder interpretation, some kind of internal mechanism in play. Thirdly, unforeseen spectral signatures. Should orbiters detect radiation or particle traces that don't align with evaporating ices, the scientific field will need to swiftly revise its assumptions. Tonight, Mars serves as far more than a mere observation outpost. Its sparse air layer, fragmented magnetic remnants, and circling spacecraft turn it into a testing ground for comet-planet dynamics. Should a chunk skim the upper layers of the atmosphere, it might leave behind substances capable of sparking brief auroral displays, disruptions in the ionosphere, or regional shifts that instruments like the Trace Gas Orbiter and MAVEN could capture. Such indicators will reach us with some delay. Data relays, limited bandwidth, and solar disruptions will postpone the information flow. Yet, even those postponed measurements will hold key markers, isotopic proportions, tallies of energetic particles, and makeup of dust particles that could prove pivotal. For weeks, researchers have practiced alternative data pathways for emergencies. This evening, those preparations will see real action. There are graver, more lingering issues to weigh as well. The danger of pollution isn't immediately apparent, yet it's significant. Suppose 3. A bears intricate organic substances beyond basic ices, perhaps linked carbon molecules or structures mimicking biology. Fragments of such stuff might land on Mars. Then, upcoming hunts for signs of life would have to distinguish native Martian processes from cosmic stowaways. The straightforward solution involves meticulous logging, time-stamped sample collections, orbital and ground-based chorus spectroscopy, and strict tracking protocols for any unusual findings. The ethical side proves trickier. Debates over whether breakthrough findings count as shared knowledge or proprietary resources have already sparked subdued disputes in control rooms. The behind-the-scenes coordination on a daily basis feels intensely human and fraught. Crews have shifted to night watches. Technicians run checks on data signals until systems buzz with activity. Volunteer groups. The very citizen observers who initially spotted past unusual intruders have set up automated tools to instantly send unprocessed images and light measurements upon detecting anomalies. Across various online hubs, skilled enthusiasts are poised to pinpoint a burst and notify expert squads. It's a network blending eagerness and vigilance. If a major event unfolds, the initial valuable alert might originate from a home setup in the global south rather than an official facility. What risks lurk? Think of 3 possibilities. In the mildest one, 3ILs acts like an odd comet. It brightens, spews particles, maybe releases minor pieces, and endures its closest solar approach before dimming on its outbound path to the stars. Post-event study uncovers quirky compositions, but nothing beyond plausibility. That alone would represent a treasure trove for science, a fresh page in understanding cometary makeup and behavior. In the next case, breakup proves intense. Big chunks create a short-lived swarm of rubble near Mars. Satellites and ground equipment face heightened tiny meteoroid impacts. A couple of delicate sensors could get harmed. In the most disturbing outlook, the entity displays traits defying typical origins. Rhythmic bursts paired with tiny velocity shifts, outputs in spectral ranges unrelated to ice vapor or organized patterns amid the fragments. Should evidence like that emerge, experts will need to expand their theories dramatically. The notion of artificial design would shift from hushed speculation to formal consideration, not as the top choice, but because inquiry demands pursuing clues no matter the direction, all while weighing options carefully. We need to sustain a measured approach in tonight's monitoring. Bold assertions demand robust proof, and our reliable tools are aimed, fine-tuned, and set to gather precisely such evidence. The James Webb Space Telescope and Hubble have completed their final pre-encounter scans. Earth-based observatories and radio dishes will continue monitoring wherever our planet's position permits. But the key spot for the most critical. The origins of these signals will come from Mars itself, a place where we have no choice but to rely on the reliability of postponed data streams. For everyday observers, the atmosphere this evening carries an odd blend of emotions. Awe inspired by a verdant intruder glowing so intensely it alters the darkness, coupled with anxiety over our world being temporarily sightless. It's easy to veer into exaggeration. Extraterrestrial scouts, signals from the cosmos, government concealments, hold back from leaping to the most outlandish narratives until the equipment delivers its verdict. Yet, avoid downplaying the tension either. We're standing at a pivotal moment. Should 3i Atlas endure and act in ways unlike anything encountered before, the discourse among scientists will balloon in an instant. Should it break apart or deposit detectable remnants on the red planet, then extended examinations of extrasolar substances will claim prime attention. Regardless, the outcome promises a more intricate and peculiar chronicle of how our solar neighborhood engages with the wider cosmos. Hobbyists tracking light measurements, sudden surges in luminosity, frequently spot them ahead of when analyzers can respond. Next, listening posts for radio waves. The object's influence on Mars's charged upper atmosphere could generate unique radio patterns, suggesting streams of energized particles. Lastly, once the lagging spectral readings reach us, scan for unusual isotope compositions and spectral features from metals that don't fit neatly into standard comet profiles. Central to this evening is a fundamental principle of research: openness combined with backups. Diverse tools, separate groups of experts, and prompt sharing of unprocessed information minimize the risk of some odd instrument glitch being confused for an otherworldly signal. Superior research withstands rigorous questioning, and this night, global attention will put that idea to the test amid high stakes. As dawn breaks across tomorrow's media landscape, we'll encounter a fresh dawn in reporting perhaps the measured dissection of an object revealing novel compositions, or bold front-page stories reshaping the vocabulary of space experts and thinkers. Both possibilities hold worth. Both represent triumphs for inquisitiveness, so gaze skyward not seeking resolutions, but sparking inquiries. Monitor the authorized broadcasts, track the enthusiast communities, and as the initial data bursts from Marsland, interpret them with equal parts amazement and wariness. This event is modest on the grand cosmic canvas, a lone interloper, a brief passage, but its ramifications might stretch vast. Soon we'll discover if a guest from beyond our stars acts as an outsider or more like a familiar presence. In any case, the cosmos is underscoring its message. Wonders persist, and the finest research stands prepared to absorb the lessons.